Good afternoon, everyone. This is the session 11 from the playlist of friction. The topic is frictional force, and the question which I have taken for this session was asked in the CBSE examination, the CBSE All India Pre-Medical Test examination a few years back. So here I have written one question. So this question says that the coefficient of friction between a table and this block A. So this is a table, and this is a block A, and this is a block B, and these two blocks are connected through a frictionless and massless pulley. This string is also considered to be massless and inextensible. So I have not written those conditions here right now, but the pulley is massless and frictionless. And this string is also considered to be massless and inextensible. Massless means that the mass of this pulley and this string is almost negligible. So 2 kg block is kept on this table, and this block B is hanging as shown in this figure, and these two blocks are connected with the help of a string. So here we have to find the maximum mass value of this block B so that these two blocks do not move. So in this question, the most important thing which we have to remember is that here this block is being subjected to only one force, and that is the frictional force. This block is kept on this surface, and the coefficient of friction is given between this table and the block is 0.2. So if these two blocks do not move, then the weight of the block B, the weight of this block B should be equal to the tension in the string, because the tension always acts away from the body and the weight will be acting vertically downward. So the weight of this block will be acting downward, and the tension in the string, it acts away from the body. So if the tension in the string is say T, then T will be equal to the weight of this this block B. And if if T is equal to the weight of the block, then this block will not move. The block will only move when the weight is more than the tension in the string, because if the weight is more than the tension in the string, then there will be a net force acting in the downward direction. So if the tension in the string is T, then T will be equal to, let us say the mass of this block B is M, so M into G. So this is the first equation. Now this block will not move when the tension in the string is equal to the frictional force. Now here the frictional force will be acting in the opposite direction, and the tension, since the tension acts away from the body, so the direction of the tension will be as indicated by this arrow. Now since these two blocks are connected by the same string, therefore the tension in the entire string will remain the same. So the net force which is acting, the frictional force which is acting on this 2 kg block will be acting on the left hand side, and the tension in the string will be acting as shown by this arrow, that is on the right hand side. That is, tension will be acting away from the block, and the frictional force will be acting in the backward direction. So so we can say that from this block A, this tension T will be equal to mu mu mg, because T is equal to the frictional force. Let us say that this frictional force is, I am just taking as Fs. So this Fs will be equal to mu into N, when N is a normal reaction. So this will be equal to mu into the mass of this block, which is equal to 2, and into G. So here g is the acceleration due to gravity. So the value of mu is equal to 0.2. This will come to into 2 into g. Now from the equation this form, so we can consider that this as a second equation. So from this equation 1 and 2, I am getting that mg will be equal to 0.2 into so 0.2 into 2 into g. Okay. From the equation number 1, tension is equal to mg, and from the equation number 2, the tension is equal to 0.2 into 2 into g. So from here, g and g will get cancelled out, and so m will be equal to 0.4 kg. So the mass of this block B will be equal to 0.4 kg. And if so, this is the maximum mass of this block B, so that the two blocks will not move. And so the correct alternative will be D, that is 0.4 kg. So I think I hope that you have understood the solution of this problem. Here the most important thing which we all have to remember is that these two blocks will not move. Let us consider first of all this block B. This block B will not move only when the tension in the string is equal to the weight of the block, and this block A will not move when the tension in the string is equal to the frictional force. So with the help of these two concepts, we were able to get these two equations, that is equation number 1 and equation number 2, and we were finally able to find the value of the mass of this block B, which is equal to 0.4 kg. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question, but the topic will remain the same, that is friction. So till then, have a nice day. Bye.